rational expressions, but here we're going to have unlike denominators. So these notes start off with how to find the least common multiple of polynomials. And when you would think about why you would need to do this, it's because to put problems like this together, you'll need common denominators. So way back in the day, when you had to add 1/2 to 1/4, you would have to switch that over to 2/4 using what was called the least common multiple. I've rewritten problem 1. Pause if you need to get caught up. But when you look at 18 and 15, you're thinking, whoa, these are large numbers. If I was finding the greatest common factor, this would probably be kind of quick. So I'm going to look at 18 because it's larger, and I'm like 18, 36. But as I'm trying to count up, it's a little bit tough to count up. So you're probably pulling a calculator out. And then maybe you land on 90, and you're like, oh, well, 15s I can kind of count up by 15, 30. Okay, cool, 30 goes into 90. So I think 90 is going to work out there. And then you check it out, of course, and make sure it does. But it's not enough just to have m. You have an m squared over here. So you could multiply this by m to give you the shared common multiple of m squared. And then kind of the same reasoning applies. Well, b squared doesn't work, so I'll use b cubed. Go ahead and box that. Now, problem 2 is going to be a little bit more challenging because let's rewrite it. We've got x squared plus 8x plus 15. But then on the other side, you have x squared plus x minus 6. So here's what the temptation might be. Well, why not just multiply the entire thing by the other and call that the least common multiple? Well, they would be multiples of each other, but they wouldn't be the smallest possible value you could get. So we'll factor these guys. The one on the left gets factored to x plus 5 and x plus 3. The one on the right gets factored to x plus 3, x minus 2. So let's see, by circling this in red, so don't write this, what's shared. These two values are shared. So I don't have to worry about that. This, however, is not shared, nor is this. So I know that the least common multiple, and I should probably skip a line so that you think this isn't just coming from the left part only. I know they have to have x plus 3, because that's shared, but I also need them to have x plus 5 and x minus 2. If these were the denominators of fractions, where I had something up top, and I had two separate ones, if I wanted to put these suckers together, I would have to have this going on. Now let's see how these actually get applied. So it's up to you to pause this here and finish 3 and 4 on your own. All right. Now we're going to talk about the application of this business. So I'll rewrite number 1. Let me see. I think I have a larger slot here. Yeah, I do. So these are polynomials in the denominators. And yeah, I know these are just monomials, but this is a catch-all. They're going to grab everything. So I'll rewrite a plus 1 over a plus a minus 3 over 3a. Now I got a little bit of an issue. The left fraction is over a, the right fraction is over 3a. But if I wanted to think about this as a least common multiple problem, I'd be like, well, they both have to have 3. They both have to have a, no squares necessary. So, I am going to be able to leave this one unchanged, but this one's going to have to change. So I'm going to multiply this problem on the left, and if you have room in your work, you can sneak times 3 over 3. And let me make that a little neater. I'm going to make it neater because if you do have the room, then you're going to write it like this, so that we can clearly see that 3 is going to go with the a plus 1. So I'm going to rewrite this, but I'm not going to distribute yet. So I'm going to have 3 times a plus 1 plus a minus 3. I'm not bothering putting this in parentheses because this is not a minus sign, and it's not anything that I have to worry about distributing. But in this step, by doing this, I am able to put everything together in 3a. And I didn't distribute because sometimes that's a little bit of a time saver, but nothing really cancels out here, so it would have been okay to take care of that in the first step. So here's 3a plus 3, as I distribute it out, plus a minus 3, all still over 3a. Let's see how much room I got here. Then I combine everything I can in the numerator, 4a, and then 3 minus 3 goes away, over 3a. And here's the deal. These a's cancel out, and I only have 4/3 after I do all that work. Problem 2. Y minus 2 over y squared plus 4y plus 4 plus y minus 2 over y plus 2. I look at this and I'm like, well, I can't find the least common multiple of that, so I'm going to factor the bottom into y plus 2. And I could write this as y plus 2 squared, so I don't know. I won't, just because I think it'll help us see this extra step, but I don't care if you do it that way. That's totally fine. And then over here I have y minus 2 over y plus 2. Now, I'm not going to bother rewriting this entire problem because this actually works out nicely as far as the space goes. And here's what I mean by that. It just happened that on the right side I can get the common denominator over here and write y plus 2 over y plus 2. So now these two guys completely match up, and I'm ready to combine these. On the left fraction, I'm rewriting y minus 2. I'm skipping a line only so that it looks neat as you view this. And then over here on the right, I have y plus 2, y minus 2. I'll go ahead and distribute this, and I'll get y squared, well, minus 2y plus 2y goes away, and then I have minus 4. All over y plus 2. But in this step, I will write an exponent of 2 in my denominator to simplify that. Looking from the left to right, I see a positive y squared that I can take to the left. I see a positive y, and then I have minus 2 minus 4 is minus 6 over y plus 2 quantity squared. Now I look at this and I'm saying, what are the factors of negative 6 that add up to positive 1? So I'm going to write this as y plus 3 times y minus 2 over y plus 2 squared. And that last step is necessary to factor because you never know, you might end up canceling something out in the denominator, in which case you would be closer to having a simplified answer. And I look through this and I think we're good to go. So those are two separate problems, one in my opinion that's a little more straightforward and one that's a little bit more complicated. So make problems 3 and 4 on your own problems. And with these later problems, we'll break these into a separate video so that we can have a stopping point here.